All right, I got cut off in that last video, so I'm going to briefly go over this problem again so that way you have a good understanding of how to read an open manometer, and then we're going to do some practice on the next slide. So, like I was saying, when you have an open manometer, you have this pusher-word, okay? You've got the gas that's in the bulb that's filling up and it's pushing on this side, and then you have the atmospheric pressure that's coming in pushing down. And let me actually erase some of these marks so you can kind of, oh, no, I'm just adding more. So you can see a little bit clearer. There we go. So you can see, just observing qualitatively, that the pressure in the atmosphere must be higher than the pressure that's in the bulb. And the reason I know that is you see how the liquid level is pushed down more than the liquid level over here. So that tells me atmospheric pressure must be higher than the pressure in the bulb. How much higher? Well, that difference is what the difference in height is. So if I measure the difference in the height and I see that it's 50, that tells me that the atmospheric pressure is 50 millimeters of mercury greater than what's in the bulb. So if the atmospheric pressure I know is 760 and I know that it's 50 greater than what's in here, then that means the pressure in the bulb must be 710. All right, and that's what's listed right there. So let's do some practice problems and then we'll be done with section 2. So we're going to want to solve for x, whatever it's asking us to solve for in all the manometers below. And in addition, we're going to get some practice doing some conversions for different pressure units. Excuse me. So in this first one, I know the pressure in the bulb. I know the difference in height because it's listing that here. And I'm asked to solve for what's the atmospheric pressure. So the first thing I notice is that there's no difference in height. You see that? There's 0 millimeters of mercury difference in height. So that tells me the pressure in the bulb here is the same as in the atmosphere. So if it's 125.6 in here for kilopascals, it's 125.6 out here. But the question wants me to have my answer in atmospheres. So that just takes a little pressure conversion. Let's see, 125.6 kilopascals. And I'm going to convert that to atmospheres. Remember, there's 101.325 kilopascals for every 1 ATM. And FYI, some of you may have been wondering this maybe from the previous video. On the back of your periodic table, it doesn't list 101.325. It actually just lists 101.3. It cuts it off. That's fine. If you use 101.3, that's okay. Obviously, 101.325 is just going out a few more sig figs. That's fine too. Either one's going to get you the right answer. So 125.6 divided by 101.325. Okay, that gives us an answer for this first one of, let's see, with 4 sig figs, 1.240 ATM. That does not look very clear. I'm sorry. Let me write that again. 1.240. There we go. That's a little better. ATM. So that would be the pressure in the atmosphere, specifically in units of atmospheres. All right, let's look at the second one. So this time we know the pressure in the bulb. We know the pressure in the room. We just need to figure out what's the difference. The problem, this would be easy if these both were in the same unit. We would just subtract. But the problem is they're not in the same unit. So it doesn't matter if you convert this pressure inside the bulb to kilopascals, or if we convert this one to ATM. Doesn't matter, they just have to be in the same unit, right? So I'm going to convert the pressure in the bulb, 0.78 ATM, I'm going to convert that into kilopascals. So 1 ATM equal to 101.32, oh, that's weird. It's a funky 3. All right, let's try it again. There we go. 325 kilopascals. Okay, let's figure out what that is. All right, so this pressure inside the bulb in kilopascals is 79.0. Okay, and that's kilopascals. All right, so we can see that the pressure in the pressure in the room, or the atmospheric pressure, is higher than the one in the bulb. And we could have guessed that because look at the liquid level's lower. But we want to know what's the difference, right? We just want to know what's the difference in height. So we're just going to take these two numbers, the 112.8, and the 79.0. We're going to subtract those. All right. And when I do that, I end up getting, let me give myself some more space here. So I'm going to erase this just because I don't need it anymore. Just want to give myself more room. Okay, the difference in height there is 33.8 kilopascals. And that's my answer, but it doesn't want the answer in kilopascals. It wants it in millimeters of mercury. So at this point, it's just another conversion. All right, so I'm just going to go straight from kilopascals to millimeters of mercury. I'm not going to go through the unit of ATM. I mean, it's fine if you do, but I know that everything's equal to each other. So there's 101.325 kilopascals. That's equal to 760 millimeters of mercury. God, my handwriting's terrible today. I'm sorry about that. Hopefully you're tracking, okay, because the handwriting's awful. Some days it's good, some days it's not. Today it's not. So we're going to do 33.8 times 760 and then divide it by 101.325. Okay, and that's going to give us roughly 253 millimeters of mercury. And that would be our answer there. Let me box this for our first one. All right, and then for our last one, hopefully you're kind of catching on. For this last one, very similarly, we want to figure out what's the difference again. Same thing. So honestly, I'm going to let you actually pause the video on this one. See if you can figure out this one for yourself, and then just hit resume when you're ready to reveal the answer. All right, so very similar to before. You could have converted either the bulb one or the one in the atmosphere. It doesn't matter. I went ahead and converted the pressure that's in the atmosphere. So I may have thrown you off on that one, I'm sorry. But I converted that to kilopascals. That way these are the same units. Once I did that, I took the difference between these two, which is 39.6 kilopascals. And then I converted kilopascals into millimeters of mercury. But either way, doesn't matter which way you did it. Hopefully you got the right final answer, which was 297 millimeters of mercury. All right, that completes section 2. We're going to see you in section 3.